Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, let's get to lesson 7.1.2. This lesson is called Scaling Quantities. It's not so much about scale, but it's more about multipliers. It's more about when we're finding percent of problems or fractions of problems, how we can use different multipliers to get to our answer. So let's just jump right into it. Here in chapter 5, you learned how to find the percent of a number by making a diagram to relate the part to the whole and find the desired portion. You may recall us doing that. What was it that we said? We said part over the total, right? The whole and the total represent the same thing. The part is the part. And then you had the percent, which was always out of 100. So while we use diagrams some of the time, this was my preferred method, which I refer to as the percent proportion, for us to solve a lot of those problems. This calculation is fairly straightforward if the percent is a multiple of 10, like 40%, or can be thought of as a fraction like 1/4 equals 25%. I would say that's true for the diagram, but using the percent proportion, it is good for when you have more complicated percents like 6.3% and 84.5%. But, there are different approaches that we can take, and you're going to learn more about one particular approach that's very popular today. Today, you will connect what you have learned previously about the relationship between distance, rate, and time to the idea of scale factors. You will learn how to use a scale factor or a multiplier to find the corresponding lengths of similar figures. This idea will add a powerful new tool to your collection of problem-solving strategies that will help you calculate percents. All right, so here is a distance kind of a problem. Dana's training for a bicycle race. He can ride his bike 25 miles per hour, so that would be your rate of speed, correct? And so this diagram kind of represents that idea where the distance that he travels is the upper portion of this number line broken up into 5 equal parts. So each one of these sections would be 5 miles. And then the time is in the lower portion, which is also broken up into 5 equal parts, but I don't know, what would that be, 12-minute intervals? I don't think we really even care about that. But combined, this represents the rate of speed, right? The ratio of the distance over the time is equal to the rate of speed. Actually, let me kind of show that. Remember, T equals RT? Well, when you divide T on both sides, you get, or I'm sorry, T on both sides, you get T over T is equal to R. So this ratio of the distance traveled over the amount of time spent gives you your rate of speed, which would be like miles per hour. Okay, so you could isolate any one of those variables, but the most common one that we do is having it as d is equal to the rate of speed times time. But then this would be the second most popular way of writing it, so you can get the rate of speed. All right, so one day when he had been riding for 3/5 of an hour, he had to stop and fix a flat tire. How many miles had he ridden when he had stopped? Okay, so using this diagram makes sense because, you could say, all right, well, 3/5 of that hour, there are 3 out of the 5, and then 3/5 of 25, we can actually figure that out because 1/5 would be 5 miles, so 2/5 would be 10, 3/5 would be 15, 4/5 would be 20, and 5/5, which is the whole hour spent riding, would be the full 25 miles. So just by looking at this, you can look and say, all right, 3/5 of 25 must be 15 miles. All right, so you can set that up using a diagram if you like to. Now, Matt, he's thinking about this problem slightly differently. He drew a diagram where he took 2 triangles that were similar to each other. This is the original, this is the new. And so this side length of the original, he's equating to the 25 miles as the total distance. And then he's treating this as a scale factor where he didn't go the entire 25 miles, he went 3/5 of it. So 3/5 of 25 gives you the distance that he had traveled up until he got his flat tire. So what would the equation be that would suit this situation? What do we do with scale factors? Well, we take and we multiply this number, the original, times the scale factor, and that's going to give you the new. And 25 times 3/5, if you remember that, we want to do numerator times numerator and denominator times denominator, would be 75 over 5, and 75 divided by 5 is, in fact, 15. So Matt thought of it in terms of a scale factor, whereas Tina was just looking at it as just thinking about it logically through the use of a diagram. So this last part, what connection is Matt making between finding a distance using a rate and time and using a scale factor with similar figures? Well, I guess one thing we could say is one problem, the 3/5 kind of represented the amount of time in hours, while in the other one, the 3/5 was still a number being used as a multiplier, but it is represented as a scale factor between two similar shapes. But what they have in common is the fact that in both situations, if you multiply 25 times 3/5, you are going to get the correct answer, which is 15. Okay, so using these fractions or decimals as either scale factors or as multipliers, a scale factor is a multiplier just based on its name. A factor is a number that you multiply times another factor to give you a product, right? So factors are things that get multiplied together. So we are definitely talking about multipliers here. All right, so from the previous problems, 3/5 is used in two ways. First is time in the rate problem, and secondly, as a scale factor in the similar triangle problem. I just kept on saying that. Both of these situations resulted in an equivalent calculation of 25 times 3/5 equals 15. How else could this be written? So think about your representations of portions triangle, where you can take this fraction, 3 over 5, and you can write it in decimal form or percent form, or you can put it into words or put it into a picture. What would be a couple of different ways that you could represent this equation here, but instead of using the 3/5 as your multiplier, use something else? Well, first thing I was thinking is, well, why don't we just change it to its decimal equivalent? If you took 25 times 0.6, since 6/10 is the same as 3/5, we should get 15. 25 times 0.6 is indeed 15. That is correct. And if you wanted to represent that in as a percent, percents are literally mean out of 100. So 60% would be 60 hundredths, and then you would get the same answer as if you multiplied times 6/10 or 3/5. You get 15 either way. If you did not already find it, what percent would be equivalent to 3/5? Well, we said here 60 hundredths, right? So that would be 60%. And so we could say that 60% of 2/5, instead of saying 3/5 of 60% of 25 is 15, instead of saying 3/5 of 25 is 15, but they would mean the exact same thing. So what we've got going on here is a situation where we're now taking and multiplying some kind of a scale factor or a multiplier times a quantity, and we can either use it as a fraction, as a decimal, or visualize it to start off with as a percent. And so what we're going to do for problem C here is we're going to take these three problems, and we're going to either represent that percent as either a fraction or as a decimal, and then we're going to complete the multiplication problem and declare our answer. Okay, so I'll start with 90% of 25 miles. 90% is the same as 9/10, right? 90 hundredths, 9/10. So if you change that to its decimal equivalent of 0.9, you can then multiply 0.9 times 25, and you would get 22.5. So that means that 90% of 25 miles is 22.5 miles. Okay, so you get to make your choice. Do you want to convert 8% to its decimal equivalent or to its fraction equivalent to determine what 8% of 75 is? We're going to multiply it either way, because that's what it means to find the percent of a number. This percent becomes the multiplier that you multiply times that number, and the word of in all of these situations means to multiply. So go ahead and complete 8% of 75 and 25% of 144. see if you get the same answers as me. I'll reveal in a moment after you have unpaused. So go ahead and pause, work it out, and then unpause to see what the answers are. All right, let's see what 8% of 75 is. I chose to write 8% as 800ths in decimal form and then use the calculator. 75 times 800ths is 6. So that means that 8% of $75 is $6. And 25% of 144, in this case, 25%, I can just write that as a fraction. 1/4 times 144 is 144 divided by 4. And if you don't know what 144 divided by 4 is, then just grab your calculator and do the division, and that ends up giving you an answer of 36. Okay, so when you find the percent of a number, you can convert your percent to a fraction or a decimal and then multiply it, and then your answer will be the answer. What you get as a result of that will be the correct answer to this percent problem. Okay, hold on for a second. Let me actually go back for a second. How does this relate to what we've already learned? Well, remember, if we were to take and use the percent proportion, we could have said, let me just do this one and I won't do the other two. 90% of 25 miles, the total is 25, so we would put that in the denominator. 90% is the percent, so we would put this up here, and it's this number that we're trying to figure out. So if you think about it, 25 times 4 is 100, so if you take 90 divided by 4, that's going to give us our answer, right? So we could continue solving this using our percent proportion, but we're now just giving you some more tools. Maybe it's easier to solve it this way than it was to set up the percent proportion. I don't want you to go away from something that worked really well for you, but I'm going to tell you, your parents probably do it this way because this is the way that we were taught many, many years ago. This makes sense, and in some ways will make life a lot easier to solve problems this way, especially when they say 22.5 is 90% of what number. That's going to be harder to solve this way, but the percent proportion will allow you to solve that problem. So I just want you to practice doing it both ways, and when you see the opportunity to do it an easier way with your calculator, yeah, maybe do it the easier way. All right, Josiah went to dinner at an Indian restaurant. The total bill was $38. I'm going to go ahead and highlight that, and she wants to leave a tip of 15%. So if you use the idea of scaling to find the tip amount, what would you need to multiply by? So how would you represent 15% as a fraction? Well, 15% literally means 15 out of 100. So you could write that as 1500ths or simplified down to 3/20. How would you represent it in decimal form? Well, 1500ths is the fraction, but it's also what you would call the decimal. So 1500ths is 0.15 1500ths. So you get to choose whether you want to multiply times the fraction or the decimal equivalent when solving these problems. Does it make a difference which one you choose? The answer is no. Choose whichever one works better for you. Now, I will tell you most people will choose to use the decimal equivalent because that makes it easier to use your calculator. But you don't have to. Sometimes the problems can be solved mentally better if you have it in fraction form. So either way works fine. And which way do you think is easier? Well, that is a personal choice. I think it's easier with the decimal most of the time because of the calculators. But I never discount using fractions. Sometimes that works really nicely too. So how much should I'm going to call her Josie. How much does she leave for a tip? Show your calculations. Okay, so we have to figure out what is 15% of 38. So 15% of 38 means we're going to multiply 1500ths times 38, and the answer to that question is 5.7. So that means that Josie would leave a tip of $5.70. All right, but that's for 15%. What if she decided to leave a 20% tip? Why don't you go ahead and work through that problem and see if you get the same answer as me. All right, did you take some time? Did you pause it? Did you show all of your work? We want to record our work, not just punch the numbers into the calculator and write the answer down. That is the most crucial mistake students make, is they don't take the time to record everything that they're putting into their calculator. So if they make a mistake somewhere, they can't go back and check and see where the mistake was. Sometimes the mistake is you just accidentally press the wrong number into the calculator. Sometimes the mistake is you didn't set up the problem properly, so what you did punch into the calculator was wrong. So please make sure you record. So we're trying to now find 20% of 38, which means, do you want to change that to a fraction 1/5 or just 0.2? I decided to go with 0.2 because 2 times 38 is 76, and then we've got to account for decimal places. And this would have been 7.6, but we're talking about money. So we're going to call it $7.60, making sure we put a 0 in for the pennies or the ones or the hundredths place. All right. While shopping for a computer game, Isaiah found that one. Sorry, let me start over. While shopping for a computer game, Isaiah found one that was on sale for 35% off. He was wondering if he could use 3500ths as a multiplier to scale down the price to find out how much he would have to pay for the game. So I 100% agree with that as his multiplier, but is that going to tell him how much he's going to pay for the game, or is that going to tell him how much the discount is going to be? So if Isaiah uses this as a scale factor, will he find the price for the game? And the answer is no, that's not going to give him the price. It's going to give him the amount of the discount, okay? So if it was on sale for 35% off, you're going to take 35% of the price and take that away, and you're going to pay the remainder, right? That's how sales work. So how would the diagram work for this situation? It says there is a scale factor or a multiplier other than 35% that can be used to find the sale price. What is it? Draw a diagram to show how the scale factor is related to 35%. Okay, and label the diagram as showing a discount and a sale price. I would like for you to pause for a second and see if you can do this. If you have a basic idea of how this works and you get it correct, then that is a powerful learning tool. It's also going to build your confidence that you know how to go about using strategies to solve these problems. Rather than always waiting for me to copy down what the answer is and you copying it down from me, if you can figure things out before I show you and you're getting things right, then you're going to build your confidence and you are going to become a better math student. Okay, so seriously, try and do this diagram, see if it makes sense. Remember, the total price represents 100%. If it's a 35% discount, then what percent are you going to pay? See if that points you in the right direction for what you're going to put for that diagram. Go ahead and unpause when you feel like you got your diagram set up right. All right, let's see how you did. This is my diagram. So remember, the entire price, the total is 100%. 35% was the amount that it was marked off. So that's what we consider the discount. The sale price would be the rest of it. So you've got two things that you can do here. You got two different multipliers. If you want to find out how much the discount is, use 0.35 as your multiplier. If you want to find out what the sale price is going to be, use 65 hundredths or the 65% as your multiplier. So what a lot of students will do is they'll figure out what is 35% of the price and then take that amount and subtract it from the total to get the sale price. But that's not necessary. You can do it in one step by just multiplying the total price by 65 hundredths. It won't tell you the amount of the discount, but it'll tell you the new price, and that's what you want to pay, right? I mean, that's how much you're going to pay. So it's, it seems logical to go straight to sale price. So let's say that the original price was $40. And how much will he have to pay? Okay, so which of these are you going to use? For the amount that he's going to pay, are you going to use the 35% or are you going to use the 65%? Go ahead and make your choice and then declare your answer, how much he's going to pay for the game that was discounted 35% and the original price was $40. All right, let's see how well you did. So we need to find out what is 65% of 40 because we're trying to find out the sale price, how much he is going to pay. So we will take and convert 65% to its decimal equivalent and then multiply it times 40. And 0.65 times 40 ends up being 26. So how much is the game going to cost? He's going to pay $26 for the game. Now, without even thinking, can you determine how much the discount was? Okay, so if the sale price was $26 and the total was $40, doesn't that mean that the discount must have been $14? So I'm going to go ahead and double check this. I'm going to see if 0.35 times 40 doesn't give us $14. It absolutely should. If it doesn't, then this entire theory is 100% wrong. But I'm guaranteeing you it's not wrong. So we're going to take $40 and now multiply it times 0.35, and that will give you the amount of the discount, which was indeed $14. Because 14 plus 26 gives you the total. Okay. So now you've got a new strategy in play for when you are finding percent of numbers. You can use multipliers, and oftentimes you've got a couple of different options depending on what the question is that you're trying to answer. But more than anything, just understanding that that percent can be converted to a decimal or to a fraction, and then multiply times the total to find the percent of a number. Okay? All right. So we'll be doing a lot more work with this throughout Chapter 7. We're going to apply this to sales tax, to markups and discounts, to sales commissions. We're going to do a lot of different activities where we are going to come up with a couple of different multipliers that we could use for a given situation, and then choose which one we should use to solve the problem most efficiently. By the end of Chapter 7, you should be an expert at percent problems. All right, take care. Bye.
Hey, feeling good.